So in this video I will be discussing Codeforces around 970 for division 3. So I will be discussing first 5 problems of this set. Let's start with problem number A. So in this question we are given two integer number A and B, which A represents total number of ones and B represents total number of twos, and you have to assign plus and minus in front of each 1 and 2 such that the sum of whole equation become equal to 0. So you have to tell them whether it is possible to place plus and minus in front of 1 and 2's such that the sum of whole equation becomes 0. Okay, so how we can approach this problem? So I think so it is very much easy. So let me tell you how we can approach. We will we will to greedily. We will, I think so, approach greedily. Okay, for example, we are having B's number of 2's and A's number of 1. Okay, first of all, we will utilize all number of B's among themselves, which means if I am having 3 number of 2's, I will be use 1 2 to subtract 1 2 only, and I will be remaining with only 1 2. Okay, so 1 2 remaining, and similarly I will count number of A's. If my number of A's are greater than 2, okay, so let me make the table. Okay, let if my B modulus 2 is equal to 0. Okay, which means this is a case in which my number of 2's will be subtracted by themselves only, and my number of A's will be left. So in this question, in this case, you will only check if A modulus 2 is equal to 0, then answer is yes, else answer is no. Okay, else answer is no. But another case in which my B modulus 2 is not equal to 0. Okay, so in this case, what you will check, if your number of A's are greater than or equal to 2, which means you will using that number of ones to subtract the remaining 2. Yes. So if this is true, then you will also check if the remaining number of ones are modulus 2, because they have to subtract themselves only. If they are modulus 2, then answer is yes, else answer is no. Okay. So these are the only equations which you will be using to solve this problem number A. So I will provide you the code in the comment section. You can take reference to that also. Let's now jump to problem number B, that is square or not. So in this question we are given a beautiful matrix, and a definition of beautiful matrix is that the edge, like the cells on the edge will be containing 1, and the middle and each and every other cell will be containing 0. Okay, for example, you can see the edge is containing 1 and middle one is containing zeros. Okay, so you are also given a binary, you are also given a string which is made from this matrix only. Okay, then you can see that I think so, uh, a beautiful binary matrix, and created a binary string written down all the rows of the matrix starting on the first ending with the r plus 1th. Okay, so this is the definition of the string given to you. So at the end you have to tell whether the string given to you is made by a square matrix. Okay, for example, in this case you can see only this one is square, each and every else is rectangle. Okay, so you have to tell them whether the string given to you is made by a square beautiful matrix or not. Okay, so you have to just check this only. So how we can check? So first condition is that, like, if if the n is the length of the string, then n must be a perfect square. Okay, which means there must be two integers m into m which is equal to n. Okay, yes, if this is true, then you have to check one more condition. You may notice one thing, that you can find number of zeros in this square matrix. Okay, the number of zeros in this square matrix of size m into m will be like, let me take a reference. For example, I am making a 4 by 4 square. Okay, so this is a 4 by 4 square. So tell me how many number of cells are there which are containing zeros. Okay, first of all, calculate how many cells are there which are on the edge. Okay, so the cells on the edge are, look, this is m, yes, this is m, yes. So added m plus m, and what is this? This is m minus 2, this is m minus 2, plus m minus 2 plus m minus 2. So these are the number of cells which are on the edge. Okay, and the remaining were would be zeros. So simply subtract it from n minus this. Okay, and if these are the number of zeros in your given string, then answer is yes, else answer is no. So that's how you can solve problem B also. Let's now jump to problem C, that is longest good array. Uh, Let me read the question. So, okay, great. So in this question, we are given a like definition of good array. Okay, I'm taking this only the definition of good array. Okay, and what is a good array? A good array is that array in which each that is an increasing array, which means each and every next element would be greater than your previous element. Along with that, the differences are also in increasing order. Okay, for example, if 1 2, what is the difference between them? The difference between them is 1. Okay, but now you can see the next number cannot be 3 because the difference between 2 and 3 will also be 1. So the next number can be minimum 4 because the difference between them is 2. Okay, so difference between these two them is 1, difference between these two is 2, and difference between next two will be 3. Okay, which means it can be 7, it can be greater than or equal to 7. Okay, so this is the definition of good array. Then this is the definition of good array. Okay, done. Now you are given two integer number L and R. Okay, two integer number L and R. You have to tell what is the longest good array possible from the given L and R, in which you're starting, in which your each and every number should be greater than and equal to greater than you can see greater than or equal to L and smaller than and equal to R. Okay, so this is the definition, and you have to find out what is the maximum length possible of a good array. Hope so it is clear to you. Now let's try to find the answer. Okay, so this is the worst case. Okay, let me take this only. One is this, and your R is 10 to this power 1 to this power 9. Okay, done. So if you notice one thing, that answer to that this is 4471. Okay, I'm deriving the answer from the answer only. The answer for them is 4471. So if you notice one thing, that 44227 is iteratable number, which means you can iterate till this number. Yes, if I can iterate till this number, I can simply start with adding the number. I will make initial number a, which is the starting point, which is equal to L, and a difference. Difference is initially the minimum difference can be 1. Okay, at and each and every iteration I will increase my a. Okay, if this is my a, I will add difference in that, because that this is the new a. So my new a will become a plus d, and I will also increase my d because my difference is also increasing at each and every point. So if at any index, if at any index my a is greater than or equal to b, which is this 29, then I will break. Okay, and then I will break, and you can count how many iterations you have done so far, and that is the number of, that is the length of maximum good string. So this is how you can solve the problem. So the key step was to get that even if my b is 1 in 9, then my number of iteration would be maximum this much only. So this give me hint that I can iterate on this iteration also. So that's how you can solve problem b. Let's now discuss problem d, that is hobby. So in this question we are given a permutation. Okay, and okay, let me take it here only. 3 5 6 1 2 4. So this is a permutation given to me. So if I tell you whether your this whether your this index, or I can say whether your this index is reachable by, okay, let me take another example. uh, yes, ठीक है. Okay, so if I ask you whether my 4 is reachable by 1, what does this mean? What is the definition of this? Whether my 4 is reachable by 1. So the simple definition to that is simply follow the trail. But this is a permutation. Hope you know the definition of permutation. If you don't know, you can read this. Okay, so this is a permutation given to you, and you have to tell them whether 4 is reachable by 1 and what is the meaning of this. Okay, so the meaning is simply this means that if you are starting with this index, go to the corresponding index with this number. So the number on, so you will go to index 1 because 1 is written on over here. Now this is 3. Now go to index 3. I'm going to index 3. Now this is 6. Go to index 6. Okay, going to index 6. Now you can see what is 6. This is 4. You will notice that from 1 you can reach 4. Okay, this is the only definition given to you. that my 4 is reachable by 1. Just follow the trail of the indexes. From 1 go to next one. Next, find the index of the next corresponding number. Go to that index. Go to that index. And similarly, if you are able to encounter your target in between in this trail, then answer is yes. Else answer is no. Okay, but this is not the question. Okay, along with these numbers, you are also given mm, along with these numbers, you are also given some number of integers like 0, 1, 0, 1, 1, 0, in which 1 represent that your current number is uh, I don't know the definition. I think so. 0 was black. Okay, 0 means your current number is black and white means your current number is white. 1 means your current number is white and 0 means your current number is black. Okay. Now for each and every index, you have to tell them how many numbers. Okay, you can read this also. Uh, Definition of heaven as the number of black integers that are reachable from I. Okay, if you are at this index, you have to tell them how many number of black integers are there, which means how many number of integers are there whose corresponding integer is 0 and are reachable by this corresponding index I. Okay, so for this index, I can take a reference that I can find how many integers are there which are black and are reachable from these three. Okay, from these three go to this one. Okay, from this go to this one. Okay, and from go to this one. Okay, and from one वापस return to this one. So how many indexes are covered? You may notice one thing that 1, 2, 3, 4. 4 indexes are covered. So how many black are among them? So total number 3 blacks are among them. One is 3 and one is 6 and one is 4. So the answer for one is 3. Okay. So for similarly for each and every index, find the number and just print this corresponding array for each and every index, and this is your answer. But how to solve this? So the way I solve this problem is using DSU. If you don't know DSU, you can learn about that concept. Okay, so what you can do with DSU, I think so you can solve the problem, I think so, with DSU. But how? Just make a pair which are reachable from each other. Okay, here you will notice one thing that from 1 you can go to 3. Yes, from 3 I can go to 6. From 6 I can go to 4. Yes, from 4 I can go to 1. Okay, 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 this is the one pair. Now I can check another pair because you can 5 is 5 has not come in your DSU part. So from 5 where you can go to 2. Okay, and from 2 where you can go, I can go to 5. Just write it here, which means these are the two sets which are possible in your permutation. Now if you are encountering one thing like I have given you index 1. Now tell me how many black number there which are reachable from index 1. Just find how many blacks are there in this set. Now on the number of blacks in this set are is 3. Okay, what is the corresponding for this? Is this the part? Okay, yes. Mm, I think this is only white, else all of are black. Okay, let me write this only. So uh, is my one black? Yes, I think so. All of them are black in this string. But is 5 black? No, 5 is not black. 5 is white. Okay. For one, tell me how many unique numbers are there in set? It is 4. Write it 4. Is this answer 4? Answer is 4. Yes. So for each and every index in this pair, the answer would be 4 only. And for similarly, for 5, what is the answer? In the set of 5, how many numbers are there which are colored black? That is only 1, which means 2. And similarly for 2, that is also 1. Because 2 is itself from where he can reach, and that is black. Okay, so you can see the answer is perfectly matching. Though, so that's how you can solve the problem. But D also, you will get the code in the description part, and this is a prerequisite. You must know DSO before solving this problem because that is a requirement. From making that you, I think so you can easily make the sets using DSO and just find the answer. That's all. I think so. I may have the implementation also. I think so that is wiped out. No worry, I will give the code in the description. So let's now discuss the last problem, that is problem number E, that is alternating string. Okay, so let me explain you the problem here only. Let me take an example, this only. Okay, so in this question, you're given a string. Okay, done. Now, what you can do, you're given a definition of good string. A good string is that string in which each and every character on even indexes are same, and in each and every character on odd indexes are same. Okay, so this is the definition of good string. Okay, done. Now, what you can do, you can perform two types of operation. Either you can remove any one number. Okay, either you can remove any one character from your string, or you can change any character to any other character. Okay, so this is the definition. So these are the operation given to you, and each and every operation costs 1 point. Okay, done. And also, what you in the definition of good string, a good string is always of even length. Okay, done. Now you have to tell them what is the minimum cost required to make given string to a good string. Okay, done. You can perform the removal operation at most one time. Okay, so hope so the all of the conditions are clear to you. So let me tell you how you can solve this problem. So if your the length of given string is already even, for example in this case you can see the length of given string is already even. Okay, then what you can do, you can never perform the first operation, because if you remove any character from the string, the length will become odd, and you cannot perform operation. The odd string is always not a good string, and you cannot perform more than one operation also of this type. So if the length of string is even, then just count the maximum of for each and every indexes and find the answer. For example, in this case, the maximum occurrence at odd index is 2, okay, which is of D, and maximum occurrences at even indexes is of A, that is also 2. Okay, done. Which means this must remains. They must remain. Which means except this, change all of the number to this only at even indexes. Okay, done. So this is so what is the length is 6, which means 3 minus 2 and 3 minus 2 is equal to 1 and is equal to 1. So you must change two character in this string, and that will result to a good string. So this is how you can approach the case of even strings. But main case arises for the odd cases. Okay, for odd cases, what you can do, let me take an example of this string. Okay, for odd cases, what you can do, just simply make a map. Okay, so okay, if I'm writing character, okay, let me write it here. E J I B M Y Y J N U. Okay, so this is the uh, string given to you. So how you can approach this problem is simply just maintain maps. Okay, I will tell you how you can maintain. So just for each and every reverse part, okay, how you can, so okay, let me take an example. For each and every index, find two counts. What is that count? The maximum occurring index at that point. That is for each and every odd. You must differentiate odd and even. Okay, this is for odd. Let me take this is for the odd occurrences. This is for even occurrences. Let me write it odd. Let me write it even. Okay, and make it index also 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, done. Hope so it is clear to you. Now what you can do, you can maintain maps. Okay, for at this point, just maintain a map that how many. Mm, I think so. I can explain it better in another way. Okay, done. So just maintain maps. Okay, what is a map? Simply map is a in this you will make a map of character comma int. Okay, done. And for each and every index, just store it. For example, in this case, your occurrence of u is 1, and you will maintain two maps. Okay, one map will be for the odd indexes, and another map will be for even indexes. Okay, done. And for the just and next at the next iteration. Okay, I'm making it for differentiating. Just for sample, I will making this one only. Use one, and this is for odd, and this is for even. For odd, this is even. Okay, now you can see for odd, you will be remaining one only, and you notice j will be increased by one. J will be increased by one. Next index, your u is one, and your y is one. Okay, one, but your j is still one. Okay, hopes you're getting these are two maps. One is for odd, one is for odd, and another one is for even. Okay, then similarly for the next pair, you will your u is one, y is one in this pair, but in another pair, your j has become one, and your y has also now become one. Okay, done. For m, you will write u one, y one, m one. Okay, done. Now next, this is j1 and y1. Okay, done. Similarly, maintain a map in reverse order. Okay, and similar thing you have to do for, and the similar map you have to maintain for increasing order also, which you will which you will be making in this order. Okay, which you will be making in this order. Okay, done. Now for each and every index. Okay, for example, I am at this index. Now you notice one thing. For each and every index, you will be having four maps. Okay. Uh, for example, this is the front map. This is the back map. This is the front map. Okay. And you are at this index. For a current index I. For a current index I, find the map at I minus one condition. Okay. Find the map at I minus one condition, which is for even. Which is for even. But if you remove this corresponding number, each and every number which is at even position at I plus 1 will be become at odd position. Yes. So just this you have to find. Just merge both of the maps, which means map odd at I plus 1 should be merged with map I minus 1 at even condition. And similarly at map odd at I minus 1 should be merged with m mm, even at I plus 1. Okay. Okay, merge these two. Okay, by merging these two you will be getting another two maps. For example, this represents mp1, this represents mp2. Okay, now you notice, now you may use a reuse code. You notice one thing which we use, remember one thing which we use in the odd condition. Just maintain a map and find the maximum occurrence and just subtract it from m by 2 and m by 2. And similarly case, perform the operation on this map 1 and map 2. So that's how you solve problem very also. I will show the code because I have written the code over here only. Okay, okay, done. So if your length is already even, just find the maximum occurrence and subtract m by 2 n by 2 and find the answer. Done. Now but for the another case, make a reverse map. Okay, make a reverse map for each and every case. For each and every index, you will just increase your counter for even indexes and odd indexes separately and store mp1 and mp2 for each and every iteration. Okay, done. Now to find the answer, you notice one thing, I'm clearing the maps and I'm increasing the map at the end. mp1, mp2, I'm increasing the map at the end because for each and every current index I want its previous iteration. So to increase the previous iteration, I'm increasing the maps at the end. So that's the only reason. Okay, done. Now remember one thing, I told you that I have to merge the maps, right? For merging the maps, what I will do, I will simply make two maps mp11, mp22. I will merge I will merge previously mp1 in my current mp11. Okay, done. And for the next iteration, for the next index, I will merge the odd index with the even index of previous one. Okay, you can note, you know one thing, that previously my mp1 is containing even indexes. Yes, my mp1 is containing even indexes. Okay, done. And I am storing that even indexes in mp11. Similarly, for the next iteration, you know one thing, that my VR, which means reverse part of second, this containing the iteration for the odd indexes. Okay, because in the because if I'm removing the current index I, my odd index will become even in axis. Okay. Similarly for the MP22 also, and just loop among them and find the maximum and minimum among the answers will be your answer. Don't forget to add +1 because this is the answer coming to you by removing one character from the string. So that's how you can solve problem by E also. So this is all. So if you have any doubts, please comment down and stay to the next one. Thank you.